Question C says, how far to the right must D be moved along the x-axis so that the drone will fly directly above it on its circular flight path? So what they want us to do is they want us to extend D and move it so that it touches our circumference. If you look at your answer sheet, you'll see there's three ways in which they do this. We'll go through the first two. Now, for the first two, because now this represents a cyclic quad, we'll say A, B, C, D is a cyclic quad. We can then say that angle D over here is equals to 90 degrees. The reason being is that opposite angles in a cyclic quad must be equals to 180. So since this is 90 degrees, that's also 90 degrees, giving us 180. And if that is true, that means we can say that CD is perpendicular to AD, and therefore the gradient of CD multiplied by the gradient of AD must give us -1. For the gradient of CD, we will say 5 minus 0 over 2 minus x. For the gradient of AD, we would say 2 minus 0 over 1 minus x. So just so we are clear, that's x and 0 because it's on our x-intercept. It is our x-intercept. Okay, so since we know that to be true, we will say 5 multiplied by 2 over 2 minus x multiplied by -2 over 1 minus x should give us -1. Okay, let's multiply those out. We'll get -10 over 2 minus x, 1 minus x is equals to -1. We can cancel out the negatives because we can multiply with negative on both sides. And we will be left with 10 is equals to 2 minus x, x minus y. And if we multiply out on that side using the FOIL method, we'll get x squared plus minus 3x, sorry, plus 2. Then we can take the 10 to the other side. We'll be left with x squared minus 3x minus 8, giving us 0. Let's fix that. Then we can use our quadratic equation to solve for x, which says that x is equals to minus our b plus minus the square root of -3b minus 4 times 1 times -8 over 2 times 1, and we'll get that x is equals to 4.7 or x is equals to -1.7. Obviously, in this case, this is not applicable because we're working on the positive x-axis. So that means the x value needs to be 4.7 and our old x value was 3. Therefore, D needs to shift 1.7 units to the right in order for it to touch the circumference of our circle. for our second solution, we will draw a line from C to A, right? And that will be our diameter. We know this to be true because this angle is 90 degrees. So we are using the converse theorem of the semicircle to say that AC is then going to be our diameter. Yep. Then we will then go ahead and calculate the midpoint of our diameter, which would be 2 plus 1 over 2 and 5 minus 2 over 2, giving us the midpoint of 3 over 2 and 3 over 2. Okay, now that we have that, we can calculate our radius, which is going to be half of our diameter. Using the length equation, which will say 2 minus 1 squared plus 5 minus 2 squared. And this would give us the square root of 50 over 2. We will then create a triangle. So the triangle is drawn here. The triangle would be from the midpoint to D. And we already know that that's our radius. We know because we know the point of the midpoint. We know that from the point to the bottom part should be 3 over 2. And this would then allow us to calculate this length over here. So we would use again Pythagoras theorem to calculate that length. Let's call that place, let's give it a name so we know what we're working with. E. So we'll then say that ED should be our hypotenuse squared minus, in this case, let's call that from this side. Let's call that our opposite side, giving us ED as 3.2 units. Now, if that's the case, if we want to know what is the length from the 0 to D, we would have to add the 3 over 2 because we know this is, according to our point, this is also 3 over 2. So from O to D, we'll call that point O, should be 3.2 plus 1.5, giving us 4.7 units. Then we can see, because D was initially at 3, we would say then that it needs to move 1.7 units to the right.